Hello class. We're starting our third video here. As you can see, it's on the short table method. This method people often will find even more difficult than the long method. It requires a much deeper understanding of the logical operators. You really need to have an intuitive grasp of them in order to be able to follow through this short table method. You will be expected, nevertheless, to understand and utilize this method. If you look at the practice test, there will be questions on the test that will expect you to use the short table method. As you can see, I have written the abbreviated form of the instructions for using the short table method. I have also decided to use the exact same question that we looked at in the last video, the video for the long table method. So let us begin. First of all, you're going to want to create columns for each of the variables that appear in the argument. Let's just do them over on this side. P, then Q, then R. Okay. The goal in this method in testing for validity and invalidity is, we can see on instruction number 2, try to force a value of false for the conclusion as a whole and for true for all the premises. So we're going to try to make this statement not R false, and we're going to try to make each of the premises true. If we're able to do that, we have proven that the argument is invalid. We've proven that there's a way in which all the premises could be true, yet the conclusion could be false. So if what we want to do is force the value of false onto the conclusion, let's take a look here. We have not R. In order for not R as a whole to be false, R has to be true. So let's treat it this way. So maybe these lines give you the impression of what to do. We have the value of T true for R. When we then apply the negation to that value of T true for R, the result for the entire statement, for the conclusion here, would then be F. And that's what we want to do according to the rule number 2, as you can see in the top left. We want to give the value false to the entire conclusion. Now what we're going to do is look to see whether or not we can give the value T to the premises, each of the premises as a whole. Since we've given the value T to R down here in the conclusion, that value is going to have to be repeated in every instance where T is going to appear. So there's the T for this R, and since the antecedent is true, and we're trying to make this entire statement true, the consequent will have to be true. Since the consequent is not Q, Q will have to be false, since we have a negation on the Q, in order to make the consequent as a whole true. So we plug in the value F for Q, and we want to apply the negation to that. So what I've done is I have taken the F that I placed on Q, negated it, the result of which is that the antecedent is now true. We had to do that because we're trying to make this entire statement as a whole true. Given that we plugged in the value of true from the R in the conclusion into this other occurrence of R, since the antecedent is true and we have a conditional, once the antecedent is true, the consequent is going to have to be true if we want the statement as a whole to be true. Now, since I have given the value of F to Q, that value has to repeat itself for all the other occurrences of Q. And so in the first premise, I have to apply the value of F to Q as well. Since again, Q has been negated, we are then going to give it the resultant value. Since we plugged in the value F for Q and Q's been negated, the resultant value for not Q would be T. What we have here in the parentheses is a conditional, and the entire statement is a conjunction. So since we want to make the entire statement to be true, and it is a conjunction, both conjuncts are going to have to be true. This conjunct that we've been working on is a conditional. since the antecedent of the conditional is true, given the rules for the conditional, if the antecedent is true, the consequent is going to have to be true in order for the entire conditional to be true. The consequent, as we can see, includes a negation. And so for the entire consequent to be true, we're going to have to make P false, which is then negated, to yield a value of true for the entirety of the consequent. So what we have, as we can see then, is by giving the value f for P, by negating it, we have a value of true for the entire consequent, the result of which is the entire conditional then has the value t as well. So we have the value of t to reflect this entire conditional. Now notice this, since in order to make this entire conditional true, we had to plug in the value of f for p. Well, since we have to plug that value in to every other occurrence of the variable p, if we plug the value f into p in this instance, over here with this part of the conjunction, what do we have? Though we've been able to make this half of the conjunction true by plugging in the value of f to this other half of the conjunction, the entire conjunction as a whole ends up being false. We have this part of the conjunction true, we have this part of the conjunction false. Consequently, this entire premise is false. What we have done is the following. We have seen that by plugging in values so as to yield false for the conclusion, taking those values, then plugging them into the premises, we end up in a situation where we can't possibly make all the premises true while making the conclusion false. We have given r the value of true, and so true appears here. By the rule of the conditional and given the negation, this q is going to have to be false to yield the value of true here, to yield the value of true for the entire conditional so that this premise is true. We plug in false up on the first premise, trying to make this part of the conjunction true. We then have to, in order to do so, given the rule for the conditional and given the negations, give a value of false for this p. We have thereby been able to achieve true for this part of the conjunction. By giving the value of f for p, we have to plug that value in here, and so this entire premise ends up being false. What we have done is show that given what we need to do in order to make the conclusion false, by plugging the appropriate values in, we can't make all of the premises true. Since we can't make all of the premises true when the conclusion is false, what we've done is show that this argument is valid. In other words, it's not possible for all the premises to be true and the conclusion to be false. And so we leave this table blank because this table here is supposed to only represent those combinations of true and false values for the variables that identify scenarios of invalidity. Here we don't have any scenarios of invalidity because the argument is valid. This table here, therefore, is blank. I know that this is complicated. I know that this is difficult. This will require a lot of practice on your own part to get comfortable with the operators and to get comfortable with the rules for creating the short table method. It requires a good intuitive grasp of the structure of logic. But that will require a lot of practice for you to acquire that intuitive grasp.